did 2-2. We kind of did 2-3. I'll talk a little bit more about 2-3. In 2-2, we talked about, the book talks about graphical limits, numeric limits. In 2-3, they start talking about algebraic limits. That's where your homework is coming from. Even though I did it all, you didn't know what section I was doing, it doesn't matter, right? And then I went back and did 2-1 so that I could do the algebraic limit with that, right? And so we're going to be looking at a certain function today with the squeeze theorem. So it's yet another way to calculate a limit that's not numerical or graphical. The particular function that we're going to be interested in is sine of x over x. So, but this actually is a slope. This is a secant slope here. It's hard to see that it's a secant slope, but you will see that in a minute. So what I want to do is open up Desmos here and take a look at just the sine function, okay? So I'm looking just at this sine function, right? I'm going to call it f of x equals sine of x. And you should be pretty comfortable with this, right? We know the maximum of sine is 1, the minimum is -1. We know the period is what? Yes, can I say it again? 2, 5? Oh. No, I wrote equal, but it's just not showing up on the screen. The screen is weak. The camera's weak. That's sine of x, right? When does it repeat? When does it start to repeat again? 2 pi, right? About 6.28, right? So we want to be able to draw a quick graph of sine, quick graph of cosine all semester long. Probably tangent too. Once we get to the inverse trigs, we'll talk about them as well. We should be able to graph those as well. I want to create a dynamic tangent line on here, right? This is one of the assignments I asked you to do Tuesday, but I'm going to do it again now. And I'm going to pick 2 arbitrary points on here, right? So a comma f of a. So there's my first point, yes? And I want to create some point later, okay? Some point to the right. And I'm going to do that with a plus h, right? So I'm creating another point here, a plus h, comma, f of a plus h. And this is a huge part of us finding derivatives, right? We're going to use that secant slope and let h go to 0. What happens when h goes to 0? Right? What happens when h goes to 0? Those 2 points become 1 point. That's the whole thing. This is a 2.1 idea. Average velocity, instantaneous velocity. Average speed, instantaneous speed, right? But we'd like to create the secant line through that, right? And so what's my slope there? What's my slope? Right? So, right, I've got 2 points on here. This is a comma f of a. This is, I should use a different color here, right? A plus h comma f of a plus h. Right? And so this is x1, y1, right? x1, y1, x2, y2, right? So what's our slope there? Yes. So I'll say m sub sec for secant, right? Equals f of a plus h minus f of a all over a minus, a plus h minus a, right? And of course that gives me f of a plus h minus f of a all over h. Now, WebAssign sorry, Desmos does a pretty nice job of actually giving me that calculation. So I want to put that in there. I want to be able to do this. Like if I'm doing my problem in 2.1, I could do it on Desmos. I should make sure I practice with my calculator anyway, because that's all you can use on your test, right? Anybody borrow a calculator yet from the Learning Center? Anybody need to borrow a calculator from the Learning Center? Do it as soon as you can in case they run out, okay? So f of a plus h minus f of a, all divided by h, right? And you see it's calculating my slopes, right? Between those 2 points. Yes, you with me? So look at what happens. What I'm really interested in today is when the original point A is 0. And I'm close, I can't, right? So, but I'm interested in what's happening to my slope. Look at where my slope is going. Look at where my slope is going. What do you want to guess? Where's it headed to? It's headed to 1. So, we're actually going to show today several ways, and I'd like you to do it numerically. We're going to actually show that the limit as x goes to 0 of sine of x over x is 1. Right? Of course, if I plug in 0, I get 0 over 0, right? This is one of my indeterminate forms. But there's not much to do here in terms of factoring. No. Right? Fractions within fractions? No. Radicals? No. Right? So this is all my methods so far fail for this, so we need this new method called squeeze method. Okay? And we'll have one other method this semester for limits. It's called what we call rule. Okay? So our whole goal is to show this, right? That's what we're trying to do today. So I need my equation of my line. I know it's y minus y sub 1 equals m times x minus x sub 1, right? That's the equation of a line that I want you to have memorized, right? By the way, when you take your midterm, you'll have one page, front and back, of anything you want on it. Inspirational lyrics, formulas, whatever. So you can start working on it, right? Write small. I personally would write 10 pages of notes, or probably 12, and then take photos of them with my CAN scanner. So I create a PDF, and when you print PDFs, you could say 6 pages per side. So I'd have one page with 6 pages on each side. No, free. Don't. They're going to try and sucker you into paying for it. Don't do it. Just keep saying no, no. Every time you open it, you want to go pro? No. Shut up. Leave me alone, right? And so you just start taking photos in it. And so now there's other ways to do it. I think notes. If you have an iPhone, your notes will work. If you have an Android, something else will work. Morning. I sent a reply back to you with your, did you get it already? Yeah, it worked? Did you do it already and it worked? Didn't do it yet, that's fine, I know, I get it. So what do I want? Right? All I have to do is pick one of my points, and it's pretty easy just to pick a comma f of a as my x1, y1, right? And then my slope is here, right? This is my slope. So I want y minus f of a equals f of a plus h minus f of a all over h times x minus a. And that's what I'm putting into Desmos now, right? Is that okay? Now, when you do this, you could just take a screenshot of what I did in Desmos and just type it in. But that's not what I'm trying to get you to do. I'm trying to get you some real understanding. And don't you learn something better when you make a mistake? Yeah. I mean, it sucks. But this one's not going to kill you. This one's not going to make you cry. Well, it could, I don't know, but right? This one's not going to hurt anyone else. So try and do it thinking about the line, thinking about the slope, thinking about the points, right? So here I am in Desmos. I want to put that equation in. So let me see if I can do this again. So I got what? Y minus f of a, right? Equals my slope, right? Which is f of a plus h minus f of a, all divided by h times x minus a. And you see, it's already got my line there, right? Kind of nice that because I can slide h here or I can slide h here, right? Same thing, a, I can slide a here or I can slide a here. Notice when I'm sliding a, h stays fixed, right? And what is h here? The distance between the 2 points in the x direction. Right? How wide, right, that piece is. So you can see as I let h go to 0, right? And it's nice really for me to make h really close, like 0.1. I'm sorry. I'll have it. I should do left and right, but I'm just going to have it from the right. So 0 to 0.1 by pennies. So when I do that, right, I can really get close. You can see my line really doesn't look like it's changing at all, does it? And look at my slope, right? 0.998, 0.998, 0.9989, right? You can see it's really kind of slowing down to something. And of course we know it's 1. So I'd like you to do this numeric limit on your calculators, right? Soon. Something I'm not going to write down, just something I want you to do. Right, so that numeric limit, I want you to do this numeric limit on your calculators. Right, left and right. So you can already see I'm getting the limit that I want, but I want to talk about the squeeze theorem here, right? Oh, I guess I didn't really make the connection between the two yet, right? Sorry about that. If 0, 0 is my arbitrary point, right? And x comma sine of x, 0, 0 is my fixed point, right? And x sine of x is my arbitrary point. What's my slope? So slope m sub sec again, right? What's my slope? Sine x minus 0 over x minus 0. Look at it. So it's I didn't tell you, right? But that sine x over x is my secant slope. And as long as I'm talking about this one, right? This fixed point, 0, 0. The one I created on Desmos, I used 2 arbitrary points, right? And that's what I want you to do. How are we doing? We okay? I do have my remind. Oops, sorry. There's a question about test 0. If you do test 0 for me, I'll add a point to your grade. I'm hoping we never need WebAssign to take a test. but I have to, my remote class has to take their test on WebAssign. So I'm giving them a point, so I guess I could come up with a way for you to get a point some other way, but I'm worried that if something happens, one of us gets sick in the class, we might go remote. I don't know for sure if that's going to happen. I don't know what the hell they're going to do for 2 weeks if I get COVID. So we don't know, right? So let's just be ready. My other class is taking their test remotely. Can I stop someone from using notes remotely? No. So that's why I'm allowing you to use them. So I'm asking them to use one page, and I'll be able to see it on the camera of notes, right? So I'm trusting them that if I'm saying, get organized with your cheating, it'll be easier, right, than to have notes on the wall or whatever, right? So since I'm giving them that opportunity, I want to do the same for you. They're taking chapter tests, you're taking a midterm and final, but you're taking quizzes. I think the quizzes are easy, right? And so I'm trying, I've done this before with everybody face to face. I don't like to test on days, I don't like to teach on days that we test. And so since we only meet Tuesday, Thursday, if I test on every chapter, I lose 4 classes. If I test only on the midterm, I lose 1 class. Yes, it's a tougher test, but you'll have quizzes. That will make up for the grade and make up for the, are you ready for the midterm? Right, and I think the written homework will be a big part of it too. Okay, ready for the squeeze theorem. I'm going to talk about it very informally. It's in the book. I also gave you the video Khan Academy to look at, right? But just imagine at some C and some L, right? I've got a bunch of functions. So let's say this one's f of x. This one is g of x. And just forgive my bad art. This one is h of x. And you can see f of x and g of x are squeezing on h of x. You see that at that one point? It's supposed to all be one point. Too lazy. Right? So it's clear that the limit of f of x is L, and g of x is L, so the limit of h has to be L. Right? Does that make sense visually? Say again? Yeah, oh, can I say it again? Yeah, I'm going to write it too. It says, so this is my squeeze theorem, right? If the limit of as x goes to c of f of x equals the limit as x goes to c of g of x equals L, and f of x is greater than or equal to h of x is greater than or equal to g of x, right? So there's the squeeze part, right? F is always below h, which is always, f is above h, which is above g, right? And they squeeze together, right? Is that making sense? So these two squeeze together to L at x going to c, and h is stuck between them, right? And then what can I conclude? Should be obvious. So if that happens, then the limit of h of x is what? Yeah. So this is not, it's kind of graphical again. Yes, you can see it graphical, but I don't want you to answer the question and go, look, right? Because but what can I do is I can find these two limits as I have in the past. Right? I can find these two limits and show Yeah, I can find these two limits and show that this is true, and then I'm done, right? So I'm doing my algebraic limits on the outside function. And this is how I get a squeeze limit. Okay. So I'm going to start with something I know, just because my teacher taught me, that teacher, the teacher of that teacher taught them, right? Something we're passing down. And it's just that you gotta kind of remember all of these things that I'm passing down to you, right? So, and this is problem 4 in chapter 2 review. I want to show that the tangent of x is greater than or equal to x, which is greater than or equal to sine x. And this is graphical, right? Graphical, I'm gonna do this. But it should kind of make sense, right? We know what tan x looks like, right? And we know what sine x looks like. Forgive me my poor craftsmanship. And guess what's right in between y equals x? Oh my God. No, you get the idea. I already put it on Desmos, so forgive I should be a little bit more precise, but I'm too lazy. I can't, it's bad. Forgive me. Funny thing about Desmos is it's constantly running. So like if you're working on Desmos, and this is why I want you to, when you're doing this dynamic tangent line, create a username login, right? So you can save sketches. If you leave it running overnight, it will just eat up all the RAM, and you won't be able to do it. You have to restart it. No big deal, right? A couple of apps I'm going to show you to do that. Just be careful about leaving them running. It's not that big of a deal, but let's see. Y equals tan of x, right? Y equals x, and y equals sine x. Now you say, well, look, they're crossing each other all over the place. But remember, I'm getting close to 0, right? You with me? I only care about really close to 0. And we'll talk about relative mins and maxes this semester. When I'm on top of K2, am I on the highest mountain? Second highest mountain, right? Everest, right? So, but I'm still at the top of that, close to me. Known to be higher than I'm on the top there, whoever's really close to me. Like within, right? Within what? What Greek letter? Delta. Right? The height would be the epsilon, but I want to know if anyone's close to me. Right? That's a delta. So I don't care about some number way out there. I care about close to 0 within delta, right? So you can see that the red is above the blue, which is above the green. Tangent is above. Tangent of x is above x, which is above sine of x, right? And down here it changes, but then we're talking about negative, aren't we? Are we talking about negative numbers now? Okay, and then what happens to an inequality when you negate everything? It switches. So it's still going to be true. Think about that for a little bit, but we'll just deal with the positive right now. So this is pretty clear, but it's not what I want. Remember what I'm trying to find the limit of. I'm trying to squeeze what function? First thing I wrote today, sine of x over x. Trying to squeeze on that. So anybody see anything I can do with this? I've got the tan of x greater than or equal to x, greater than or equal to sine of x, right? As x goes to 0, right? So anything I can do algebraically, remember what I want. I can not divide by x. If I divide by x, what do I get in the middle? 1. And remember, I'm trying to squeeze sine of x over x. So I want sine of x over x in the middle. I don't want it on the end. Anybody? I want to manipulate this to squeeze sine of x over x. Say again, man? You can bring it up there. But if I bring it here, it becomes negative sine of x, and then it fails. It fails right away. So I want to multiply or divide. What do you want to do? Grace, what do you think? Oh, go ahead. Multiply by what? Multiply everything by sine? I like the idea of using the sign, but I don't want to multiply. Divide by sign. Let's divide it by sign. And remember, we're really close to 0, and let's just assume I'm on the positive side, right? So dividing by a positive number shouldn't be a problem with my inequality, right? So it looks like I get what? I get sine x over cos x divided by sine x greater than or equal to x over sine x. Almost what I want. Greater than or equal to 1, right? I got to do something else. I don't want x over sine x. I want sine x over x. So what do I do? Reciprocal, right? Whoa. But what happens when I when I do reciprocals of an inequality? Right. So by the way, oh sorry, this is just 1 over cos x, right? Now I could name that secant, right? But I don't want to, because I know I'm going to flip now, right? So what do I get? I get cos x is less than or equal to sine x over x, which is less than or equal to 1. I don't even have to squeeze on the right? It's already fixed. I know what this limit is as x goes to 0, right? Do you agree? What is it? 1. It's a constant height. So when I'm asking you for a limit, I'm asking you for a height, right? So this is key, right? This is key. I'm ready to squeeze. Let's see what happens. The limit as x goes to 0 of cos of x is cos of 0, which is what number? Yep. And then the limit as x goes to 0 of 1 is trivial, is 1, right? There's no way, it's always the same height. So we've got it. So I want it memorized, right? Because we're going to use it. We're going to use this limit several times this semester. There are other ones to squeeze on. You can take a look in section 2, 3, I think it's 2, 3. It doesn't matter. You're reading all of chapter 2, right? Yep. It's why you should be. So I've got it. I got what I wanted, but I want to use it now. This is so the proof of this is not ever going to show up on the test. The proof of the squeeze, which we just did, right? We squeezed this limit, right? We didn't prove the squeeze theorem. That should be obvious, right? Yes. Yes. I got mad Zoom skills even though the class isn't remote. All right, we want to apply this limit, but I need a couple of properties of limits first. I need a couple of properties of limits to do. And this is theory stuff that I think should be obvious. I would ask you to read all the properties, and they should make sense, and then you can talk to me if you're unsure about them. If you're a math major, you should definitely look at the proofs. If you're a computer science major, probably. Everyone else, don't. So I want to look at a couple of properties. Of limits. There's a whole slew of them. The sum of limits is the limit of the sum. The product of limits is the product of the limit. The limit of a product is the product of the limits, et cetera, et cetera. I'll write those two down and then one more. Okay. Let's see. The limit as x goes to c of f of x is L. The limit as x goes to c of g of x is k. So if, then these are some of the properties. The limit of f of x plus g of x as x goes to c is the limit of f of x plus the limit of g of x. Again, as x goes to c, I don't even know if you have to write it, okay? Equals L plus k. This is the sorry. Thank you. Messy Robert. My girlfriend calls me the notorious PIG. I say, you give me a bad rap. Oh, that's funny. I just thought of that. Or Piggy Smalls, she also calls me. So, the limit of a sum is the sum of the limits, right? Why is it obvious? What are we talking about with limits? Why is this obvious? It's easy. What are limits? Heights of functions or values of functions, right? So if I'm saying I have two functions, and I get the height of this one, and I get the height of this one, when I add them, it's just some new height, isn't it? The two heights added together, right? It's obvious. It's an epsilon delta proof. For this limit, I've got a delta for any epsilon I pick, right? So including epsilon over 2. If I change my dartboard to epsilon over 2, I can find the delta. For g of x, I can find the delta as well for epsilon over 2, right? So if I take my delta smaller, the smaller of those two deltas, right? I know that this limit minus L and this limit minus K are bounded by epsilon over 2 plus epsilon over 2. You with me there at all? I found the delta for this one. I found the delta for this one from epsilon over 2. I took the smaller of them. And then what happened to my epsilon over 2 plus epsilon over 2? What's that add up to? Epsilon. So I got it. I got a delta from my epsilon. So that's why I gave you that formal definition, but it's obvious. The one that's not so obvious is the product. Right? The limit of f of x times g of x is the limit of f of x times the limit of g of x is L times K. That one's not so obvious. As x goes to c, I'm just too lazy. I'm too lazy to write as x goes to c. Okay? But this one is not as obvious, right? But it's true. There's a nice proof of this by the author. If anybody's interested in seeing the author's proofs, what is it, Stewart Calculus, something like that? Let me see if I can. Stewart. Oh, Stewart Funeral Home, sorry. Stewart Calculus. There it is. Yeah, stewartcalculus.com. And then you pick your book, which is 4th edition. And then you can see supplements. It's in here somewhere. I'll find it. If you're interested, just search around. But there's a place for the authors doing all the proofs of everything. Sorry, additional topics. I gotta find it. Oh, maybe it's about the author. I don't know. There he is, James Stewart. I don't know where it is. I know it's in there. But if you're interested in seeing the author do some of the proofs, let me know. I'll find it, and then I'll put up a link on Blackboard. This one's not as obvious, but the trick here is really separating the function into the right two products, right two factors. Okay, and that's the first thing that we'll talk about right now. So, oops, sorry. It's still recording. It just hides the recording symbol when I hit that button. So let's take a look at the limit. So assuming the limit as sine of x over x, as x goes to 0 is 1, find the following. Find the limit as x goes to 0 of sine of 2x over x. So we got to manipulate this, right? I can't, if I plug in 0, I get 0 over 0, right? Obvious, yes? So I got to manipulate it, and I'll be able to turn it into a product. Remember what I'm looking for. I'm looking for this, right? So I want to separate my product from that factor to whatever other factors I get. So Diego, you got this identity for me? You remember this one? What? That's an awful quick shake. Grace? One more time. Nice. 2 times sine x. Diego, you knew that. 2 times sine x times cos x, right? So you can see I've got the factor I want. I want the factor of sine x over x, right? So I'm looking at the limit as x goes to 0 of sine 2x over x is the limit as x goes to 0 of 2 sine x cos x over x. And now I'm going to apply that property where I can factor out something and take the limit of the factors separately. So I want to do the limit as x goes to 0 of sine x over x times the limit as x goes to 0 of 2 cos x. Right? Do you see? So whenever I'm doing a problem like this is what my goal is. To get the limit I know times the limit I don't know. And the limit I don't know, I should be able to manipulate. So what's my limit in green here? 1. And the other limit I can do very quickly by just plugging in, right? I can plug in 0 to cos x, yes? So I get 1 times 2 times cos of 0, right? So I get 1 times 2 times 1, which is 2. And there's the limit. Nice one to do, check yourself numerically whenever you do one of these for me. It won't be in the homework. Well, you got that chapter 2 review where I said do 4 and 5. I already have the answers up there, so but try it without looking at the answers. Grace, you're on Earth. You're not lost. So I use my trig identity thanks to you. Yes. And remember what I'm looking for. I'm looking for sin x over x, and I see it. So you still at C, I have 2 times sin x and cos x over x. So I want to separate this one because I know that limit. 1, and then how can I do this limit? I can just plug it. You okay there now? Nice. I'm going to do another one, but I need another property. Okay, I want to do another one, but I need another property. Claire, you got? Let me get the whole thing in there. There you go. Okay. I need another property, and that is that a constant or a coefficient can move in or out of a limit. A constant can move in or out of a limit. Yes. Absolutely. Always will. We'll do this, and we'll do one more. We'll do one more limit, and then we'll take a little break. Okay. Sorry, missed our break window. We good? Yeah. No problem. Thank you. A constant can move in or out of a limit. So I'm saying that if the limit is x goes to c of f of x is L, then the limit as x goes to c of a times f of x equals a times the limit as x goes to c of f of x equals AL. So you can see here my constant, right? The inside the limit, the constant on the outside the limit, still going to get that constant times that original limit. This one is really obvious. I can do it a couple ways. I can do epsilon delta, or I can use my product property. Which one do you want me to do? Epsilon delta or product property? I knew you'd say that. The limit as x goes to c of a times f of x equals the limit of a times the limit of f of x, and it's done already, isn't it? It's done instantly, isn't it? Because what's the height of a as x goes to c? What's the height of a constant? The constant. So this limit is just a, so you can see I get the constant outside of the limit, right? This is a pretty important one for us to remember, because you're going to see my derivatives are limits, right? You already know it, even though I didn't teach it yet. The derivative slope of the secant line becomes the slope of the tangent line when h goes to 0. So it's a limit. The derivative is going to give us the tangent slope. And constants move in and out of derivatives. Right? So because there are limits. So it's an important one for us to remember, but let's use this. Let's do the limit as x goes to c of sine 3x over x. Now, I can do this a couple of ways, and I'm going to do it 2 more ways, and then we'll take a break, okay? So, what is it that I want again? What is it that I know? Sine of theta over theta, right? So I can do this a couple of ways. The first way is a theta sub. So I'll use a theta sub. So I'll let 3x equal theta. And it should be really clear. The limit as x goes to 0 will also give me theta goes to 0, right? So if x goes to 0, theta goes to 0. Do we agree with that? Right? We agree with that? It's pretty obvious, right? Because they're equal, right? So then what do I get from 3x equals theta? I get theta over 3 equals x, right? So the limit as x goes to to 0, of sine 3x over x is the same as the limit as theta goes to 0 of sine of theta over 3. You with me here? Now this 3 can come out of the limit, right? The 3 can come out of the limit, yeah? It comes out of the limit as a 3, not a 1/3. Do you agree? Yep, so this 3 can come out. So I get 3 times the limit as theta goes to 0 of sine theta over theta. And I know this limit, don't I? Yeah, it's 1. So constants can move in or out of limits. I've done something like this with a trig identity. I've done it with a theta sub, and I can do it also with just coefficients, right? So here's the third way. We okay here? So sine 3x over x is what? 3/3 times sine 3x over x. Right? Do we agree with that at least? Which is 3 times the sine of 3x over 3x. Sorry, I got a little messy there. We agree with that? What did I multiply by? By 1. And that's what I'm going to do this whole semester. I'm going to multiply by 1 and I'm going to add 0. I'm going to do nothing all semester. And you're paying for it. So I know that the limit of sine 3x over x as x goes to 0 is 3 times the limit of sine 3x over 3x as x goes to 0. And that's 3 times 1 again. Right? Sine of theta over theta. Sine of w over w, right? So make sure that argument and that denominator match. And then you're going to get that limit of 1. Nice. Let's take a break. Let's come back at 10:30 is fine. 2 different things. I have to talk about continuity, but it's kind of boring, so I'm gonna wait till Tuesday. And I'm just gonna go right to derivatives. So I'm kind of cheating a little bit here into chapter 3. So we're talking about shortcuts and long cuts. And if you were in my pre-calc class, Brian, Grace, Diego, Ryan, I tortured you with this on purpose so that you would be really good at derivatives right away. You can thank me later. Money is accepted. Cash money is fine. Even though I'll probably get fired. Just make it 20,000. I owe 20,000 on my master's degree still. So give me 20,000 and I can quit teaching. I'll go make pizza again. Shortcuts and long cuts. Let's talk about long cuts. Let's talk about shortcuts. Some of you probably already know the shortcuts, and you're going to say to me, why do I have to do the long cut? Because I said so. Don't ask, same thing. Don't smoke pot. Why? Because I said so. You might like it. Could be bad. Could be damaging. Or you could get arrested. Not in Maryland, right? Depends on how much, but so don't complain about the long cut. Get really good at it. It's going to be on the midterm. It could be on the final, right? So we say f prime of x. Oh, sorry. Thank you. Because I'm not too smart sometimes. I hope you're not overwhelmed with all the stuff I put up this weekend, but I had energy. So it's like when I can work, I get work done. And I'm ADD. When I'm focused, I'm focused. When I can't focus, I can't do anything. It sucks. Come on, let's go. Work. Any day. Damn it. Come on. It works. You ever drive and shoot at the red light, make it turn green? It usually works for me, but. Oh, by the way, if there's a shooting, what are we going to do? No, on campus, if there's a shooting, we all get, right, our phones are on. We're going to get an alert, locked down. What are we doing? Shut the door. Shut the door. Move away. We're probably going against this wall. All of us? All of us.
That wall? That's terrible.
All the way. We don't want to be seen under the door or anything.
Everyone's right here.
No, if they say lockdown, we're not running out. You don't know who's outside the door.
Being next to the door so they don't see.
Yes, all along this wall, all along the back wall. Who's closest to the door? Me. Why? Because if they come in, if they break in, if something happens, I'm going to attack them. And you're going to run out. I'm serious.
Really?
Yes.
Is that what I said?
What's that?
Oh,
If they're already in the class, we're all dead. And hopefully they're shooting me first. If they shoot me first, I'll stay alive as long as I can, and all of you run out. I'm trying to get this to work. Come on. Let me just turn it off real quick. So look, if they say lock it up, you don't want to be running out, right? And I don't want anyone to take that risk. I'd rather us just stay in here, lock everything. Will lock. The door locks instantly if you shut it, and then we just, it sucks. But there was a shooting at high school the other day, right? Was it Maryland?
no. Which is Maryland, right?
Yeah.
Maryland?
Yes, Maryland.
Yeah, it was really recent. Is that really?
Yes. Sorry. Welcome to America. Welcome to America.
Yeah, welcome to America.
All right, I got it working here. And this sucks, you guys are talking about stuff like that. I can't say this. If you're having some mental issues, there are people here that can help, right? So if you don't have a personal doctor, there's someone here that can help, and it's confidential. If you go in there and say, I have a gun and I'm dangerous, you know, you're probably in trouble. But if you go in and say, I'm depressed, someone might be able to help you, right? Come on, please, no signal. Well, doesn't look good, does it? Oh. Come on, please. Don't listen to this part of the recording. It's still recording. Oh, there we go. Nice. F prime of x. Yes? F prime of x. Anybody seen it before? Nice. F prime of x is called the derivative. Is the limit as h goes to 0 of f of x plus h minus f of x all over h. The book notation uses delta x instead of h. Just make sure when you're reading that, when you read delta x, it's one variable. It's not like delta times x, right? You with me on that? I don't like using delta x. I find it gets a little bit annoying to write. So I like this h goes to 0. What is the right-hand side here? What is this piece I have in green? It's the slope of the secant line. When h goes to 0, the 2 points become the same point. And this is now the slope of the tangent line. So f prime of x is the derivative of f, provided the limit exists. So I need that limit to exist for my derivative to exist. Now, we've done a lot with this already. And what's going to happen? I'm going to see polynomials. I'm going to see complex fractions, fractions within fractions. And I'm going to see conjugates. So I'm going to see radicals, right? So far, that's it. Those are the only ones we're going to be dealing with for now. So let's go for an easy one. You ready? Yes? New page is okay? If y equals x squared, or f of x equals x squared, f prime of x is what? Who knows the shortcut? 2x. Good. Anybody else know that? Anybody else know that? Only one? Anybody else? 2 of you knew it? Yvonne, Ryan, nice. So the 2 of you are going to be bitching to me about the long cut. So go ahead, get it over with now. Do I have to do it? I don't want to do it. I don't want to. No, yes, you have to do it. The secret shortcut on a polynomial, if y equals x to the n, y prime is n times x to the n minus 1. Y prime is the same as f prime. Yes, you okay with that? F prime of x, y prime, same thing. Yes, you okay? Right, because remember when we learned functions and we had to learn about f of x, and you're like, what the hell is f of x? It's just y, right? So notice my shortcut. Notice I had a power of 2. And what does this thing say? Take my power, and move it out front as a coefficient. So you see the square is coming out front as a 2. And then do what to my power? Reduce it by 1, so x squared becomes x to the 1. All right, long cut. When it's a polynomial, I do this, okay? When it's a polynomial, I do something else. So you can go right into the actual formula, but I like to do this. I like to say that f of x plus h is x squared, but I'm putting in x plus h, right? You with me? When I'm doing the substitution, I like to start with empty parens where my variable is. Empty parens, right? Nothing inside of them. Do you see the x squared there? Something squared, right? Yes? Okay. And then I'm going to use my favorite 4-letter F word. Do you know it? That's not my favorite, but I'll use that one. It's better for in mixed company, I guess. So x squared plus hx. I'll get you fired for that. I didn't say anything. Right? So I got what? I got x squared plus 2hx plus h squared. Is everybody okay there? Everybody comfortable there? So remember, I know my formula, f of x plus h minus f of x, right? That's my difference quotient part, difference part. So what I like to do is I put my f of x down here, which was just x squared, and I'm strategically lining it up. I'm making sure that the pieces of f of x line up with the pieces of f of x plus h. Because what am I going to do with them? I'm going to subtract them, right? I'm going to subtract. So these are going to go away, right? So I have f of x plus h minus f of x is what? 2hx plus h squared. There's my difference part. I'm doing the difference quotient. How do you remember me? How do in pre-cal remember the difference quotient? Difference quotient. You should have been tortured with it so that it would have made my job easier. Difference is upstairs, the numerator I'm subtracting. That's a difference, right? Quotient, I'm dividing. You see that I'm dividing by h now? Yes? And what do I get? I get h times 2x plus h all over h. My h's are going to cancel. So I know f prime of x is the limit as h goes to 0 of 2x plus h, which is 2x plus 0 is 2x. There's my derivative. Pretty simple, huh? At 0, what's the slope of that line, that tangent line? What's the slope of that line? 0, right? Plug in 0 to this, and I get that slope. When x is 1, that green tangent derivative tells me the slope at any point. So when I plug in 1, I get slope of 2. So that green line is the slope of 2. That's how simple the derivative is. That's how powerful it is. It's telling me the instantaneous velocity at any, right? Tiny amount of time, right? Instantaneous. Smaller even than a nanosecond, right? It tells us a lot of things. You'll see when we start doing applications, when you take your physics class, how many of you are taking physics next semester? After Calc 1, you take physics 1, physics for engineering. And you'll see they'll be doing derivatives right in day 1, which is why we're asking you to take Calc 1 first. Pretty powerful. Pretty damn powerful. Let's do another one, okay? So a nice thing to do on this is to draw tangent lines as well. When you do a function, you have a function and you find a derivative, also find a tangent line, right? So let's do f of x equals x minus x cubed. I'm just going to factor this real quick. What is it? 1 minus x squared. So it's what? 1 plus x, 1 minus x. Is this okay? Yes, everybody with me? So it's done something like this, right? So let's say we're going to find this tangent line at 1/2. Well, I need to find the derivative first, okay? So we're going to do shortcut quickly, and then we'll do the long cut. Oh, I don't want to do this to you. This should I do this? Kind of torture. Oh, it's too late. I'm sorry. I'm going to do it. I'm going to torture you a little bit. So what's f prime of x? Anybody do this one quickly for me? 1 minus 3x squared. What is a derivative? What is a derivative? A slope, right? So what's the slope of y equals x? 1. Slope of x, slope of y equals x is 1. You could kind of think of the shortcut there. Bring down the power of 1 as a multiplier, and then you get x to the 1 minus 1, which is x to the 0. We don't really like to say that x to the 0 is 1, but... And then what's the other shortcut? Bring down the 3 and reduce the power to 2, right? 3x squared, yes? I don't want to. I'm gonna just do the tangent line. I'm not gonna do the long cut on this one. I won't ask you to do a long cut bigger than x squared. Okay. I'll do another one in a second, but let's just get this tangent line down. So at x equals 1/2, what's the slope? That's f prime of 1/2. That's 1 minus 3 times 1/2 squared. So 1 minus 3/4, which is what? 1/4, yes? And what is f of 1/2? It's 1/2 minus 1/2 cubed. So 1/2 minus 1/8. Yes? So what, 3/8? Yes, you with me? So what's my tangent line? Y minus 3/8 equals 1/4 all times x minus 1/2. I could make it look prettier, and I probably will ask you to do that. Prettier is, it's questionable. What does it mean to be prettier? But it looks like I'm going to have y equals 1/4 x plus 1/4, right? You agree with that? Yes, we agree. Grace, you got enough of it? So on my calculator, or for me on Desmos, yes? Can I go to Desmos? Give me a sec, sure. What does it say? Yeah, you got it? Right, we all agree, yes? I do my fractions in my head. I don't care how you do them. Do them the way you want to. Don't hate fractions, though. I have a half brother. After I get a derivative, I can pick an arbitrary point in the domain, find the y value of the function, find the slope of that tangent line, find the equation of the tangent line, graph the function and the tangent line, right? I can graph a point in my calculator. It just takes a little bit of work. So you can look that up. Graph a point on TI 8384, right? So what did I have? I had y equals x minus x cubed, right? And I had the point 1/2, I forget already, help me, 1/2 comma what? 1/8? Oh, 3/8? Nice. And my tangent line was y equals 1/4 x plus 1/4? Yeah. Boom. Look at that, baby. Remember, a tangent line hits how many times? Once. Did it hit over here? Did it hit the function again over there? Yeah, but I don't care about, when I'm talking about a derivative, I'm talking about a limit really close to what? C or whatever, right? I'm talking about this limit really close to here. I don't care about anything way else in this system. All right, let's do another one. These are fun. I mean, if you're a nerd, they're fun. So learn to love it. Fake it till you make it. Pick functions, polynomials, nothing higher than x squared. Try them. Okay. Let's do one with a radical. Let's just do y equals square root of x. What's my shortcut? Anybody know it? What is it? Yeah, 1/2. Square roots, 1 over 2 square roots of x. 1 over 2 square roots of x. What's my exponent here in this one? What's my exponent right now? 1/2. You see the 1/2 out front now? And then the power, so I'm going to reduce the power by 1. 1/2 minus 1 is what? Minus 1/2. Minus 1/2. A negative exponent means reciprocal, so the square root of x moves downstairs. I'll write that, okay? I'll write the shortcut, yes? This is x to the 1/2, right? So y prime is 1/2. The power comes down, and I reduce the power, right? So 1/2 minus 1. Yes, you with me? So I get 1/2 times x to the minus 1/2. A negative exponent means reciprocal. So I get 1 over 2 x to the 1/2. But x to the 1/2, 1/2 power means square root. So 1 over 2 square roots of x. Shortcut, ready for the long cut? Long cut. It doesn't say long cut in the book. It says find the derivative using the definition. Or I'll say using a limit, right? I'm just saying long cut because I'm bored out of my mind. So when I had polynomials, I kind of did it separately. When I have a radical, I'm going to do it right into the formula. So f prime of x is the limit, as h goes to 0, of square root of x plus h minus square root of x all over h. I should be able to see the original function evaluated at x plus h minus the original function all over h. And again, what is this? It's the slope of the secant. What do you want to do? I want to get a replacement function, right? What happens if I plug in h right now? What happens if I plug in h there? What do I get? 0 over 0, right? 0 over 0 is different things at different times. It's called indeterminate. I don't know. Sometimes it'll be 1. Sometimes it'll be the derivative. Sometimes it won't exist. I'm going to use a conjugate, yes? So I'm going to use square root of x plus h plus square root of x all over itself. I'm only allowed to multiply by 1. I'm allowed to add 0. I'm allowed to multiply by 1. You haven't seen me add 0 yet. You will. It's exciting. Joking. I don't want to mess with which part. What's your gut say? Numerator or denominator? Don't mess with which one. Denominator, because that one I didn't get my conjugate from there. So I'm going to use where I got my conjugate from. I'm going to manipulate that. And we already know this. Right? Robert already tortured me with this. I get x plus h minus x. Right? You agree? We agree? I get the first term squared minus the second term squared. The first term squared just kills the radical, minus the second term squared. Again, it kills the radical. And now the x is canceled. Don't let me go too fast. I feel like I might be going too fast. Right? I'm your Uber driver. Don't wait until I get you home and then write me up with a bad review that guy went way too fast and why the hell is he playing that rock and roll music all the time, right? So, same thing with the cop. If the cop pulls me over at home and says, here's 50 tickets, I've been following you, not fair, right? Pull me over now, give me 1 ticket, right? So, let me know if I'm riding too fast, right? Thank you. So I get h over h times, right? And then finally my h's cancel. And the question is, can I plug in h0 now? Well, definitely, because I don't get a 0 upstairs. I'm trying to get a replacement function for that 0 over 0, right? All right, I'm ready for my limit. Yes? F prime of x is the limit as h goes to 0 of 1 over x plus h, square root of x plus h plus square root of x, right? All of that in the denominator. And I can let h go to 0 now. When I let h go to 0, I'm not taking the limit anymore. I'm already at the limit. So I say 1 over square root of x plus 0 plus square root of x. So it's 1 over square root of x plus square root of x, right? That sum is in the denominator. How many square roots of x do I have there? 2. I get 1 over 2 square roots of x. There it is. Pretty easy, right? We've done this already. You know how to do this. We did it in pre-cal. We did it in our limits, right? What's the main difference here is I'm not getting a single number. I'm getting a function that will give me the slope anywhere on the curve. I like to say I have a variable slope, right? My slope is variable at any point. If you imagine me on the hill with my skis, the slope is changing. The slope of my skis are changing, right? It's variable, and the machine that's telling me is the derivative. Let's get a tangent line at 1. If x equals 1, f of 1 is square root of 1, which is 1, right? Yes, you with me? And what's f prime of 1? 1 over 2 square roots of 1, which is 1 over 2, right? And that's my slope. So what's my equation? Y minus 1 equals 1/2 all times x minus 1. Am I going too fast? Going too fast? Oh, it's worried because I'm zooming too much, sorry. I've been zooming for 2 years. I hope I never have to use Zoom again. Oh, I have the class tomorrow. A little blurry, I'm sorry. X minus 1 equals 1/2 times 1 to the x minus 1, right? We're going to make that look a little prettier, yes? Let me see if I can get a little clearer on the screen, sorry. Is that clearer? A little bit, yeah? Y minus 1 equals 1/2 x minus 1/2. I'm going to add 1. It's a coincidence that I'm getting these things to match, sorry. Right, the other problem. Go ahead. Wait. Yeah. I'll say that one more time. Wait. So I'm only going to get the plus minus if I start with an x squared and then square root both sides. If I'm just talking about the square root of x, then I'm talking, and you'll see what I mean here in a second. Does anybody need a second? Well, one more time, I can't hear you. Always, you're going to be asked to use the long. For now, you always do the long version. Didn't I tell you were going to complain? I told you. I knew, it's okay. I mean, just get used to it. Get over it. You'll be fine. No big deal. Life goes on. Get comfortable being pissed off because it's going to happen always. What did I get? Y equals square root of x. So Grace, you'll see. Right? Square root of x, you see it? It's just the positive anyway. Right? And then what did I get? Y, what did I have? 0.11, right? 1 comma 1. Yes. Tangent line, y equals 1/2 x plus 1/2. Is that right? Boom, look at that. It's a beautiful thing. You love when you get it right. Love when you get it right. Yes? Squirt. S-Q-R-T, squirt. And I think there's functions somewhere. I think somewhere. Yes? Pretty cool, huh? What happens when I do the derivative at 0? What happens to my tangent line at 0? Imagine me skiing, and my skis are. What happens when I ski onto this? Face plant there. And my skis are sticking straight up in the air, right? Yes, can you visualize it? Teacher's dead is always a great visual, right? But what happens when I plug in 0 to my derivative? Undefined. What's undefined mean? Two answers. Positive or negative infinity. When the tangent line is vertical, the steepness is unbounded, right? But can I tell it was from the positive side or from the negative side? I can't tell. Right? So, but the key is when my derivative is undefined, I know there's a vertical tangent line.
Yeah, I have a question. So, this is from a tiny bit ago, but if you scroll down.
Yes.
Okay, yeah. Okay, wait, no, a little bit more down. Okay, so between these two lines, f prime of 1
Yep.
and y minus 1, like,
Yep.
where's the length between them?
Good. So I said magically, I want the tangent line when x is 1. Anything in the domain is fine for you to test your derivative. So I pick 1 into my domain. I found the height on the function, square root of 1 is 1. So now I have a point 1 comma 1. If I picked 4, I would have had the point 4 comma 2, right? So I can pick anything in the domain. And then I get the slope at that point. The derivative gives me the slope at that point. So I plug in 1 into my derivative function. So I get 1/2. And then I'm just doing my equation with my line. Y minus y2, so y minus y1 equals m times x minus x1. My x1, y1 are both 1, my slope is 1/2. In Desmos, I can type this in like this. And your calculator can't. Right? And typically we want to put that tangent line in y equals mx plus b. The 1/2 came from the derivative, right? We had a derivative, arbitrary derivative, 1 over 2 square roots of x. And so when I find the slope, I put that value where I want the derivative tangent line with the value of the x. All right, that's enough for today. We'll do some more next class.